my lovely viewers. In today's video, we want to look at predicted 2026 Waec Chemistry Practical Part 1. That is question 1, titration. Predicted question on titration. What you should be expecting on your chemistry practical exams. Question number 1. That is to say that titration, the question that you'll be expecting on your titration, that is what we are going to tackle today. Almost 95% accurate. 95%. So just go there and study this question that I'm about giving you now. Now, what is the question? Now, it is mainly for people who are preparing for Waec, for teachers, for students preparing for West African Senior School Certificate Examination called Waec. Now, the question goes: A is a solution of 3.9 grams tetraoxosulfuric acid in 400 cl cubes. B is a solution containing 4.0 grams per dm cube of sodium hydroxide. We are now asked to titrate A against 20 or 25 cl cube portion of B. That is what? The volume of what? Base. Using what? A methyl orange as what? As indicator. We are now asked to repeat the titration 3 more times and record our results. Now, from the information, we are now asked to calculate the average volume of acid, the concentration of solution B in moles per dm cube. Remember, the concentration of solution B has already been given in what? In grams per dm cube. Now we are now asked to calculate what? In moles per dm cube. There are 2 types of concentration. Concentration in mass per dm cube, concentration in what? In moles per dm cube. Concentration in mass per dm cube, it is called mass concentration. While concentration in moles per dm cube, it is called molar concentration. Take note of that. Second one, calculate the concentration of A in moles per dm cubes. Here we are given in grams per cm cube, which we need to convert it into what? Into grams per what? Per dm cube. The next one is for concentration of what? Of the pure acid in grams per dm cube. We are asked to calculate what? The concentration of A in grams per dm cube. The next one we are going to, this question is very fascinating. Percentage of purity. This question is what you should be expecting, because in the paper, in the what they gave you to use and neutralize is a percentage of purity. There is a purity of acid is given as what? 98%. That is why you should be expecting this particular question. Now, percentage of purity and impurity in what? Solution what? A, and of course this is our equation. Now, what we are going to do is that to answer this question, for us to be able to calculate the average volume of acid, we are going to prepare our table. After preparing our table, we'll now use it and answer this question. So stay tuned. If you are on Instagram or TikTok, a complete video of how to solve all these parameters is already uploaded on Waec YouTube channel. Look at there, Waec TV. Waec TV. Just go there, search for Titration 2026 Chemistry Practical. The video will pop out and you see how we calculate all this. Burette reading. Under burette reading, we have a rough. We have rough titer. We have first titer. We have second titer. We have third titer. All of them are what? In cm cubes. Now after that we have final reading. We have initial reading. And we have what? Volume of what? Volume of acid used. This is how your table should be. All right, this is how your table should be. Now you are rough here, you are rough tighter here. Of course, let's look at 13.00. When you do your titration, we have already determined how the endpoint of this 2026 chemistry practical, all right, Waec chemistry practical. So the endpoint has already been determined. If you are watching for the first time, go to my YouTube channel. Just go to YouTube, type how to determine endpoint 2026 endpoint by Ojemai. The video will pop up and you see how endpoint is being determined. So now here we have what? Your initial of the rough is what? 0.100. To get your volume of acid, minus this one by this one, show you are 13.1, 13.00. And at the end, ideally, if you are doing your titration, you are expected that you take the initial here will be what? 13.100. And at the end, when you titrate, because this acid, if you look at the volume of that burette, is calibrated from 0 to 50. Do you get that? So when you get to 13, that acid is still enough for you to continue. But if you don't want to do it that way, you can refill your acid and titrate again. Which that is the method I'm going to use that so that it will not confuse you. Alright. So I will say my initial of this the first titer is 0.1, and at the end I have 12.40. Here I minus this one, give what? 12.40. The next one I have 0.00. I have what? 12.40. I have 12.140. And the third one I have 0.00. I have what? 12.1. 12.30. 12.130. Now if you are a teacher, the range of your values for your students should be either -1 or +1, -2 or +2. That should be the range of the differences. So if the endpoint of this one, now if the first student is using 12.40, the other one can say 12.50, 12.56 or 12.30, 12.20. Do you understand? That is how to prepare table for your but the range of the value should be what? -1 and what? -1 or +1, and -2 or what? +2. Is that understood? So at the end, this is how we are able to generate our table so that we can use and calculate the first one, which is what? The average volume of acid. This is our table. Now let's go to the first one, which is what? Average volume of acid is equals to, what you are going to see is that first, don't use rough, use first, second, or you can use first and second divide by 2, or you can use first, second, third and divide by what? Divide by 3. So we have first titer plus second titer plus third titer divide by what? Divide by 3. At the end, you put the word CMQ. Please, it is very, very important. CMQ. You have to bracket and put what? The unit. So first titer, what is the average? Look at average volume of acid. You are using this value. Alright? We are using the one of first, second, and what? Third. So we around have what? We have first is what? 12.4 plus 12.4 plus 12.4 plus we have is equals to 12.40 plus 12.40 plus 12.40 divide by what? Divide by 3 equals to 37.10. Alright? Divide by what? Divide by 3 equals to what? 12.37 cm3. This is what you are going to have. So our volume of acid is what? Is 12.37. Volume of acid 12.37. 12.37. Then we now go to the first one, calculating what concentration of solution B in moles per dm3. Just take a look at this table while I clean this one to start calculating these parameters. To calculate concentration of B in moles per dm3, there are two major formulas you can use to calculate concentration of B or A in moles per dm3. There are two formulas you can use to calculate concentration in moles per dm3. Number one, but before looking at them, I will say, okay, H2SO4 is given as what? 3.9 per 400 cm cubed. NaOH is given as what? 4 grams per what? Per dm cubed. This is what is given. This is what is given in your question. Two formulas you can use to calculate concentration in moles per dm. Number one of the formulas is molar concentration is equals to mass concentration over what? Molar mass. The second formula is 2 CaVA over CbVb is equals to Na over what? Nb. These are the two formulas you can use to calculate concentration in moles per dm cubed. I told you that moles per dm cubed is called molar concentration, while grams per dm cubed is called mass concentration. So when you are asked to calculate mass concentration or concentration in grams per dm cubed, look at it is called mass concentration. We are going to make this mass concentration the subject of formula. But in this one now, we are asked to calculate concentration of B in moles per dm cubed, concentration of A in moles per dm cubed. So which formula can we use to calculate the mole concentration? And remember, you cannot use one formula to calculate the two concentration in moles per dm cubed. You use one to calculate either A or B, and use one to calculate the other one. So in this case now, we are going to use this one. Now, using this one is not a choice. You have to determine. What do I mean? You cannot use this one first because concentration of B is not given in moles per dm cubed. It's given in what? Grams per dm cubed. If in the question, look at the question here. If one of the concentration is given in moles per dm cubed, you don't use this formula. Go direct and use this formula. If any of the concentration, either A or B, is given in moles per dm cubed, and you are asked the other concentration in moles per dm cubed, you go straight to use this formula. But if none of the concentration is given in moles per dm cubed in the question, look at our question here. None of the concentration is given in moles per dm cubed. Therefore, we are going to use this one first to get the one of to get one, and use this one to get the last one. So we are going to use this formula first to get the one of B in moles per dm cubed. We now use this formula to get the one of what? A in moles per dm cubed. Is that understood? Now let's go. You say that mass concentration is equals to molar concentration is equals to mass concentration over what? Molar mass, which is equals to, what is your mass concentration? Remember, we are looking at what? Concentration of B. Look at it here. Concentration of B in moles per dm. What is your B? This is our B. This is B, and this is what? A. Do you get that? Now, the concentration, mass concentration, I told you it's always expressed in grams per dm cubed. What is concentration? I have 4. Divide that. What is the molar mass of this? Sodium hydroxide. What is the molar mass of sodium hydroxide? Look at Na plus O plus H. Na here is what? 23 plus what? O is what? 16 plus, yes. Plus what? 1 equals to what? 40. So we have what? 40. At the end, it equals to what? At the end, we have what? Concentration of B in moles per dm cubed is equals to what? 0.10 moles. Let's leave it in 3 decimal place. 0.100 moles per what? Per dm cubed. This is our first question. This is I. Are you following? It is very, very simple. Now let's go to the second one. We say that having used this formula for the first one, we now go ahead and use what? Use this formula. So we are going to use this formula. So we say I now concentration of E in moles per what? dm cubed. Using this formula, CEVE over what? CBVB is equals to what? NA over what? NB. Now we are going to make CA the subject of formula. Making CA the subject of formula was CA is equals to what? Cross multiply. This one go up. The one that has 3 parameters will go up. So we now have what? CBVB NA over what? Over VA NB. Now CB here is the concentration of your base, which is we have. Do you get that? So now, what is your volume of base? Volume of base is what? What you use as your prepared. In the question, they say 20 or 25. So the one we use, the one is normally used in the laboratory is 25. Alright? So volume of base is what? 25. Look at VB is equals to what? 25. VA is equals to what? 12.1. Look at the endpoint. Where is the endpoint? We have 12.37. These are the 2 parameters. Are you following? Now, what is your mole ratio? Mole ratio is acid is to base. Look at what? This one, Na is acid. Mole ratio of acid. What? Look at the equation. You get mole ratio from the what? From the balanced chemical equation. Now, what is the balanced chemical equation? Look at nothing is here. So mole ratio is what? 1. What is in front of this sodium hydroxide is what? 2. So the mole ratio of acid is 1. The mole ratio of base is what? Is 2. That is how to get your mole ratio. Are you following? So now, going to that, we say Ca is equals to, what is the concentration of base? We have 0.10 multiplied by volume of base. Look at it there. Volume of B, 25. Multiplied by what is the mole ratio of acid? Look at it here. Is what? 1 divided by what is the volume of acid? What we have in that our table, that is average volume of acid. We have what? We had 12.37 multiplied by what do you have as your mole ratio of base? Look at it here. Mole ratio of base, that is sodium hydroxide. I have what? 2. So at the end, Ca now will now be equals to what? We have 2.5 divided by 24, and Ca will now have what? 0.101 moles per what? Per dm cubed. So our Ca now, look at concentration of the second question. Concentration of acid is what? Is this one. Is that understood? So the next question we are going to calculate is what? Concentration of the pure acid and what? Impure acid. Are you following this? Look at the question here. A is given in what? Grams per cm cubed. Grams per what? Cm cubed. Then how do we get our grams per dm cubed? Ordinarily, it is grams per dm. Any time you are asked to calculate concentration of what? Grams per dm cubed, you use this formula. Make mass concentration here the subject of formula, but not when it is given, when the question is given in per cm cubed. Anytime you see per cm cubed like this and you are asked to calculate grams per dm cubed, it is simple. You say that here we have I concentration of A in grams per dm cubed. It is simple. What you simply do is that 3.9 divided by what? 400. We have to change it. Multiply by what? 1000. This is how to calculate your concentration in what? In what? In grams per dm cubed. When the question is given in what? In cm cubed. Don't go and use this formula. Do you understand? So now at the end now, we have what? If you divide this one, cancel here, cancel here, cancel here, cancel here. So 10 at 3.9 times 10 divided by what? 4. At the end we have what? 9.75 grams per what? dm3. So our concentration of A in grams per dm3 is what? 9.75 grams per what? Per dm3. That is how to calculate. Then the next one that is more important, the one that is more important is what? Percentage of what? Purity. This question, you have to be very, very careful because it is likely that they were going to ask it. Do you get that? Percentage of what? Purity. How do you get our percentage of what? Purity. Now let's go. Before getting, remember we are looking at the one of what? The one of A, not B. So let me write the value of my CA. CA is equals to what? 0.1101 moles per what? dm3. Because I'm going to use this value, alright? For us to be able to calculate the percentage of what? Purity and impurity. What is the formula? We say that this one is what? IV. Percentage of purity. Percentage of purity is given as what? Is equals to mass concentration of pure acid over mass concentration of impure acid multiplied by 100 divided by 1. This is the formula to calculate what? Percentage of purity. Now we are going to look at the mass concentration of the pure acid and look at the mass concentration of the what? The impure acid. I will now use it for our problem. Did you understand? Did you understand? Now, what is the mass concentration of pure acid? The mass concentration of pure acid is the one always given in the question. In grams per, remember I told you that mass concentration is expressed in what? Grams per dm3. So the one given in the question in grams per dm3 is the mass concentration of the acid, of the pure acid. Now the one that the one of the impure acid is the one that you now ask to calculate using what? This formula. So here the mass concentration given here is gram per cm3, but we now change it to what? To dm3, and we have what? 9.75. This is the one of what? Pure acid. How do we get the one of impure acid? You use this formula. Do you understand? You make mass concentration here the subject of formula. So you say what? Mass concentration of pure acid is equals to, what is the value? 9.75 grams per what? dm3. Mass concentration of impure acid now is equals to, make mass concentration here the subject of formula. You are going to use this formula. So mass concentration will be what? You cross multiply. Say molar con multiply by what? Molar mass. Are you following? You cross multiply with what? Molar concentration times what? Molar mass. That's the, what is the molar concentration of acid? I told you that molar concentration is always expressed in what? Moles per dm3, while mass concentration is always expressed in what? Grams per dm3. So molar concentration of the acid is what? Look at it here, moles per dm3. So we say that concentration of impure acid is equals to molar concentration 0.101 multiplied by, what is the molar mass of the acid? Tetraoxosulfate. What is the molar mass? Of course, is 98. How do you get that 98? Look at it now. H2, that is H2 plus what? S plus what? 4O. Here share is what? Atomic mass of hydrogen here is 1. Alright? So 1 times this 2 give us what? 2 plus sulfur is what? 32 plus 4 times 16. Oxygen is 16. You give what? 60 what? 64. At the end you have what? 98. So multiply by what? 98. So at the end we now have what? 9.90 grams per what? gm cube. This is the concentration of what? Of the impure, and this is the concentration of what? Of pure. Do you understand? Do you understand? Do you understand? Now, what do we do? Now subject it into our formula. Percentage of purity. You say percentage of purity will be equals to what? What is the mass concentration of pure acid? 9.75 divided by, we have what? 9.90 multiplied by what? 100. At the end, percentage of what? Percentage purity will give you what? 98%. Just multiply this one by this one, divide by this one, give you what? 98%. And that is what is given in the purity of the acid. What is given in the purity of the acid now is what? Say relative density is 1.84. Now, purity of the acid is 98. And this is our 98 that we have. You can see that this question, calculating the percentage of purity, is most likely to come out. Now, if you have gotten the percentage of purity, what is the percentage of what? Impurity. Percentage of impurity, you see, percentage of impurity is what? 100 minus what? What is the percentage of purity? Minus 98, which will give you what? 2%. Percentage of impurity is what? 2%. While percentage of purity is what? 98%. We have come to the end of our titration calculation. So this is what you should be expecting in your exam, especially most concentration of A in moles per dm³, in grams per dm³, in concentration of B in moles per dm³, and in grams per dm³. The question might not be far from it. If you are watching for the first time, as you are watching the video, do well to subscribe, do well to my YouTube channel, do well to like, comment. Any way you can follow me on all my social media platforms, do so. Thank you for watching. God bless you.